This apparatus is known as the Fireman's Aquarium, or the Bang box, and the reason we call it the Bang box will become evident during the presentation. What we have is a compartment, and it has glass sides so we can see the reactions that are occurring in there. At the top we have some explosion vents, and we have an ignition source, it's an electric arc that will ignite the gas mixtures we introduce into this compartment. And we have as our fuel supply LPG. You can actually just hear the gas flowing through a little pipe down there. Now the thing about LPG is it's heavier than air, so we've got to cheat a little bit. We have a little stirrer. And this fan pushes the LPG up towards the ceiling area. So we're creating similar effects to what you may encounter in some scenarios in a compartment fire situation. Now moving in sympathy with the gas flow is a little counter down here, which moves at roughly 15-second intervals. So what I'm going to do now is reset the counter back towards zero. I'm going to turn on the gas supply, the ignition source and the stirrer, and what will happen is when we form a lower flammable mixture, that is a mixture that is just lean enough to ignite, we'll get a small explosion. Just have a look at the colour of the flame that's produced from that ignition. So we have gas, stirrer and ignition source. Just before we actually get the ignition, you may see some lengthening of the flame around the igniter. That indicates to us we're getting close to the lower flammable limit. Approaching 15 seconds now. Slight lengthening of the flame. Okay, so what you saw was a mixture that was only just flammable. In this scenario, what we're going to do is the exact opposite of before. We're going to build up the gas supply to beyond the upper flammable limit. I've reset the counter back towards zero, and I'm introducing gas into our compartment. Now from our previous experiment we know that around about that point there we got an ignition at the lower flammable limit. What I want to do now is actually build up the gas supply right through the flammable range up towards the upper flammable limit and actually exceed the upper flammable limit. At that point it should be impossible to ignite the mixture in there by turning this switch on, unless we dilute it down back to the upper flammable limit. So if you can imagine a compartment fire situation in a building that's well insulated and well sealed up, what will happen is eventually the fire will consume the oxygen that's available. Once it's done that, it will stay hot for quite some time after that oxygen's been consumed, most likely above the polarisation temperature of the contents of that room. So what's happening in that room is that the contents are breaking down into almost pure fuel. So we're building up the we're building up the fuel supply within that room to the point at which it will be too rich to ignite. If a firefighter comes along and opens up that compartment, he supplies the missing ingredient, oxygen. Now we're getting very close to the point where we're about to approach the upper flammable limit. We'll just take it a little bit further to be sure we've exceeded that point, and then we'll switch the ignition switch on. Okay, I'll give a countdown now. 5, 4, 3, 2, 1. Okay, so it's too rich to ignite in that atmosphere. What we're going to do now is actually open up that compartment. If you can imagine, these are the firefighters that have arrived at the fire scene. The smouldering object has started to ignite again, and that is enough to provide an ignition source for that energy-rich mixture in there. You see in this scenario here that there was a large volume of gas that actually was forced out of the compartment into the adjacent areas. That's the difference between a leaner event, and flashover is generally leaner, although it can be quite rich, and a very rich event such as a backdraft. Okay, in the third scenario we're going to show you a different ignition source. We're actually going to conceal the ignition source from the rest of the compartment. In effect we're forming a little compartment within the big compartment, and what's going to happen now is going to change the point in the flammability range at which the mixture in the main compartment will ignite. So you've seen ignition at the lower flammable limit and the upper flammable limit. Where this ignites, well, we don't know. We'll find out. So reset our timer back to zero. What we'll do now is turn on the ignition source, the gas and stirrer. So So what's happening now is fuel is being introduced into the main compartment with a separation of the fuel from the ignition source. Now if you can imagine in a normal house fire situation, that is the room on fire, the fuel, the smoke, is leaving that room and flowing into the other compartments. If we open up that compartment carelessly, what can happen is we can introduce an ignition source into that fuel or smoke mixture outside the original compartment. You can see now that we're well within the flammable range from our previous experiments, yet we still have no ignition. So the fuel concentration is building up, it's probably approaching the ideal mixture, yet we still have no ignition. I can see a slight lengthening of the flame, so we're getting close to ignition. You can see the difference in power generated when we ignite a fuel mixture at a different point in the flammability range. So you've seen an effect similar to flashover, you've seen an effect similar to backdraft, and now this third event, which has previously been undefined in the international fire community, we're calling it delayed flashover. And you can see they can be much more powerful